So I'm going to start off and give the high-level overview of some of the policy and some of the institutional constraints that we face in BLM in designing long-term monitoring, and I think that's always important that we address those, because at the end of the day, we can focus a lot on statistics and quantitative approaches, but a lot of times it's the social aspects of it, our policy drivers, what makes us a special snowflake, and why we can't play ball with you that inhibits our integration. I think that's a theme that we'd like to touch on a bit. So Steve and I work for a project that we're faced with this challenge of, can we collect data once and use it for multiple applications through space or time? And that sounds really grand, but there's a lot of challenges in doing that. But first, for those of you that aren't familiar, as Jen said, we're with the BLM, largest land management agency in the U.S., managing over 900,000 square kilometers, over 130,000 stream kilometers, including Alaska, in this mission of sustaining health, diversity, productivity of public land. How we got there is in 1976, FLIPMA. This is kind of our organic act mandate like the Forest Service has. The Congress directed the BLM to manage public lands for multiple use and sustained yield. So as many of you are aware, public lands like BLM lands, we've been in the news a lot lately, we use them for a lot of different uses, from oil and gas development, timber harvest, grazing. So a lot of economic productivity coming out of them. But there is this idea that we're going to do all this activity while preventing undue and unnecessary degradation to these systems. It's a real challenge, especially when we're working in these pretty arid, fragile ecosystems. Western Oregon's kind of the anomaly that it's wet and we have big trees on BLM lands. So how do we do this? First of all, I just want to point out some of our challenges, that we are a federal agency, but we're a federal agency broken up into over 115 different units on the landscape. That's a challenge because we are not a predominantly top-down agency. If we develop a mandate, it comes down from the Washington office, and it's a thou shall, and everybody gets in line and does it. That's a utopian world that none of us live in. But I'd argue in our agency in particular, there's a lot of autonomy at that field office scale, and that creates a lot of challenges in terms of integration of monitoring information. Because we need data, and we need data at a lot of different spatial scales. At the finest spatial scale, we're implementing a lot of treatments, and we want to know, are those treatments effective? We permit a lot of activities like grazing, oil and gas development, timber harvest. We want to know, are they causing degradation of ecosystems? All the way up to statewide reporting that in the public land statistics, we have a mandate to report to Congress and the American public on an annual basis of how our public lands do. But increasingly, because we know that things like floods, fires, disease, drought doesn't honor state boundaries, we've been thinking about, well, can we also report at eco-regional scales? And ultimately, we have commitments to report nationally on the condition of our public lands. So this idea of, can we collect data, the same type of data, for whether it's terrestrial resources, stream and rivers, wetlands, that we could use at these different spatial scales. And Steve is going to focus on not so much what we collect, because we've had a lot of luck in standardizing what we collect, but how can we use that information to make inferences from treatment effectiveness all the way to bureau-wide reporting. This came about because in 2004, the General Accounting Office and the Office of Management and Budget came to the BLM with a pretty simple question. Said, can you please make a pie chart of the proportion of BLM lands in good, fair, and poor condition? And we said, no. And they said, but you're spending millions of dollars a year to collect data, you can't make a simple pie chart. So much to our surprise, instead of them saying, we're going to pull your funding until we see more accountability, they said, we're going to give you more money. And so they've allocated over, varies tremendously, but about $8 to $12 million. And that sounds like a lot, but this is from Alaska to New Mexico, Western Oregon to Eastern Montana to monitor all of our natural resources. And they gave us some rope and said, go forward and do good work, or hang yourself and we'll see what happens, and the verdict is still out. But what came of that is the AIM strategy, assessment, inventory, and monitoring. This idea, can we promote integrated monitoring throughout the agency? A lot of people in those 115 different units think that their management questions are very unique, but when you drill down to it, they want to know something about the location, the abundance, the spatial distribution, or the condition of some resources. And they actually share a lot of commonalities in terms of vegetative conditions, soil conditions, water quality. So can we standardize this? So AIM is a little unique because it's not necessarily a program trying to do one thing. It is a strategy in which we're trying to apply to improve the efficiency and effectiveness of our monitoring activities. And so it's a strategy that's made up of a couple different fundamentals. And one is just trying to standardize if you're going to go out into the field, what you measure and how you measure it. So we don't have a lot of special snowflakes all using their different vegetative or water quality techniques. Trying to provide guidance on how they determine where they drive the truck to based on different management objectives. So appropriate sample designs. We used to have that as statistically valid sample designs. That messaging really rubs some people the wrong way, so we have to soften them a little bit. The idea of integrating remote sensing technologies, this can be anything from stratification of design, to site scanning, to causal assessments once we've collected data, to trying to go from more design-based inference to model-based inference, trying to get spatially explicit estimates on the landscape. Important but kind of boring stuff like electronic data capture and management. And at the end of this idea of structured implementation, making sure that what you're collecting, where you're collecting it, is relevant to your management objectives and how you go about doing that. And so in the aquatic realm, we've been active for about 5 years now, going strong for about 3 years. We have about over 1,500 data points collected, and this is increasing by about 400 points per year that we're collecting. In the terrestrial realm, a lot more resources given the focus of our agency. They're collecting thousands of data points a year and are up to north of 15,000 vegetative plots throughout the western United States. So a tremendous amount of data being collected on BLM lands if you include our AIM and what's called the landscape monitoring framework that Steve is going to also talk about. So my last slide is just focusing on a couple of the challenges that we're facing. Germane to this workshop are mainly the first two. This idea of, can we integrate sample designs? If we're going to collect data once and use it multiple times, how do we do that? Can we do it all the way from the point of monitoring restoration or reclamation effectiveness? Do we want to incorporate that type of data into national level reporting? To this idea of how we're allocating points to the two kind of competing factors of status or condition estimates, given the vastness of our resources versus trend, because we have policy objectives related to both status and trend. And then not as much going to be addressed in this workshop, but I wanted to put it out there for maybe side conversations with that, is this idea of setting expectations. How do we set the bar to say whether something is good, fair, or poor, across very diverse environmental gradients? To this idea of the precision of our field methods. And if we're going to collect data once and use it for multiple applications, we need to make sure that the precision and accuracy of that data is appropriate to apply, not just from the national scale, but all the way down to the plot scale. Because we all know when working with land management agencies, you can give them population estimates, but at the end of the day, they want to go down to the reach and the my favorite pixel or my favorite plot or reach. And that can be dangerous because at some point the data might not be appropriate to make inferences to that finer spatial scale. So Steve's going to spend the rest of the time talking about some of those specific challenges related to integration. You're going to focus a lot on the terrestrial component of our program, but I'd really just stress that the resource is almost irrelevant. Try and focus on the issues that they're germane to wetlands, rivers, streams, vegetation. See?
I have to ask the arrow.
Forward.
There you go. Okay. Thanks, Scott. You just stole my intro there. I appreciate that. I actually like all those questions that Scott had at the end, and I figured, sorry, I'm changing the schedule. We get maybe somewhere between 5 hours and 5 months we could address all of those specific questions and get down to it. But seriously, integration multiple sample designs across spatial extent will be the remainder of the talk. Just real quick, we're talking about site-specific monitoring program, a little bit of background, a little more info, I don't think it's going to hurt. So thumbnail sketch of our two major terrestrial programs, AIM and LMF. Along the way, in the spirit of the workshop, identify some areas, technical issues that haven't been resolved, or subject to alternative interpretations. Input feedback would be very useful. And if we have time, because I'm trying to allocate maybe half of this talk for discussion, we can talk about something that we are just thinking about in terms of integrating targeted probability sampling. So the terrestrial AIM samples upland vegetation. We have the aquatic side, and that's what Scott's in charge of. Monitoring plots are typical grassland shrubland plots. They're 30 meters, there's 3 transects in a spoke pattern. Use line point intercept to pick up along each of those transects. To pick up percent species, cover, species composition, bare ground, canopy gaps, and we also measure height and measures of soil stability. Fairly standard for vegetation monitoring in the uplands. I don't quite, was it 2013 or so, they came up with a master sample for the terrestrial and the aquatic, spatially balanced master sample to facilitate design for construction of similar designs across the BLM lands. And with that, when using the master sample, your designs, we're working at areas that are 10, 20, 30,000 square kilometers, so large spatial extents. And the master design tends to be, for the terrestrial uplands, terrestrial system, 5 panels of 50 plots. So there's a 5-year rotation period, and revisits begin at the starting in year 6, which we're actually in the process of designing for a couple of our project areas. Now, despite trying to standardize our sample frame using the master sample, snowflakes. BLM has lots of snowflakes. And that's what my reference to intensification. Because something comes up. And there's a hot issue, there's a grazing permit renewal issue. It's like, oh, geez, we're going to have to look at the, across BLM, we have this bird species. It's called the spotted owl or the shrub staff, otherwise known as the greater sage-grouse. I worked in Oregon for a bit. I had to get that one. So all sorts of things pop up, and then it's like, well, I went pretty quick to master samples at one point for 35 hectares. Intensifications, we need higher density. So we're going to do a unique grid straw. And it may only be invoked, meaning monitored for 1, 2, or 3 years, sometimes longer. So intensifications are common throughout. Real quick, stratification. The terrestrial side of this program has evolved. You will see all sorts of combinations of, there was no stratification, there's a pseudo eco-site map drawn and used for the sample frame. PPS, land-fire biophysical setting, however, has sort of become standard way for a standard stratification mechanism. The sample selection, again, there's all sorts of combinations, but one's proportional to the size or PPS, and other designs, they will oversample sage-grouse because they're interested in it, undersample anything with any kind of trees, forests, whatever. The frame extends real quick here. District field offices. This is the extent at which, for instance, we use master sample. And this is an example here of the result of a master sample. This is Southeast Oregon. This is the Malheur field office in the Villa district. Then we have sagebrush focal areas that come up, PHC, priority areas of conservation. These are, of course, sage-grouse related. and then grazing allotment. So it's 10, 20, 30K plus down to like 94 and even smaller. So these are the spatial extents of the frames of these various designs. It's a fairly simple, Tony went over this in his presentation, in terms of aim weights on a good day on a very simple situation. It's simply how many points do you have in the strata divided into the area. Quite simple. The other terrestrial program we have is called Landscape Monitoring Framework, LMF. This is a collaboration between with NRCS, Iowa State University, the Center for Survey, Statistics, and Methodology, CSSM. This program monitors uplands using very similar methods as AIM. This monitors only BLM lands. It's modeled after the NRI program, which is private lands. NRCS is private lands. So, and the goal of LMF was to report out across district offices, field office. Actually, the analysis domains are like eco-regions, states or eco-regions. So it's doing something similar to what AIM is trying to do, or is doing. AIM is driven by field offices, the people in the field. They have a specific issue, they have a specific resource they want data for. They drive those type of designs. LMF is much more broader scale oriented. LMF is also designed is very different. It's different, not very different. It's stratified by sage-grouse habitat types, which back in about 2010, they said, well, those there on the left, that's type 1, that's prime. It's based on basically soil series in a sense. And type 2 is other rangeland. And it's quite interesting because if you, as we go through this presentation, you'll see prime sage-grouse habitat popping up in type 2. And the issue there is definitions of sage-grouse habitat continue to evolve. And this is circa 2010. So like the best guess at the time. So stratification, they determined sampling intensity, and this is largely driven by their NRI experience. For the statistical certainty that they wanted, they figured 2,000 unique points each year over a 10-year period. Proportionally distribute 1,000 across type 1, type 2. 2014, they wanted to intensify within the prime, what we call the prime sage-grouse habitat areas. So another 1,000 points. That's proportional in stratum 1 across the western U.S. Following NRI, LMF is the two-stage design. Following NRI, LMF is a two-stage design where the primary sample unit is quarter section. And based on the number of points they wanted in a primary unit, the number of points they wanted over the 10-year period, plus information about response rate, they figured out the number of quarter section sections that they wanted. They also call those quarter section segments. And so they sort of did a little, back calculation and said, well, we want X number of segments, and they're distributed using polygons, which are constructed by state and stratum, with 20 evenly distributed segments within each of the polygons. And this is the way that they've ensured spatial balance, at least at the segment level. There's one little tidbit here. This, if you ever look at a quarter section map, you'll see all sorts of different sizes. Quarter section is about 160 acres. So section 640 or 160. It is surprising. I have worked with quarter section maps in Southwest Wyoming, and it's often amazing, some of the sizes. As part of this process, they actually took the liberty to modify. They came up with a quarter section that was like 200 acres. They modified it, bring it back down to 160 or thereabouts. So in the documentation, they said they came across quarter sections that range from 40 to 640 acres. So that necessitated, basically they're manipulating the section maps so that they don't have really big and really small sections. Try to keep it at 160 on average. The secondary units, I mentioned that they are monitoring up to 2 points per segment, but they select 3 using a restricted random procedure. And they will number the points, and they go up in the field, they go to point number 1, number 2, number 3. The first 2 points are monitored, point number 3 stops. They don't need to go there. If point number 1 or 2 doesn't get monitored because it's inacceptable, it's a non-response, then they go through all 3, and all the, what we call the response and disposition of each point is recorded so that they can do the proper weighting down the road. This is just, maybe this is like a stat fact. I have to have sort of like an equation. This is sort of like an equation. What's interesting, at least to me, in these calculations here is the fact that they're taking into account segment size, and that comes back to the potential for having unequal segment sizes. And so if you work through the, I mean, you guys are sharper, better at figuring this out than I am, but if you work through the math there, you can see, oh yes, they're adjusting for segment size. It's built in there. So, as Scott had pointed out, well, I think we're up to like, what, 19,000 plus, that's, 16, 17 circuit there. So, as you can see, there's quite a bit of geographic overlap between AIM and the element points. Then, is there a pointer in here? And then, if you take a look here, you see, oh, wow, it's like LMF, even though this is the year we're getting the database and stuff. You take a look at the LMF coverage, you go, there's some areas there where we're increasing the coverage of the of our VLM lands with LMF data. So LMF is an important contribution to what we call, the AIM monitoring program. It is more commonly being used in some of our analysis. Sometimes there's a little bit of a problem getting this message out to field folks, like, hey, we have AIM, and we have AIM. And so you can access both when you want to request an analysis. So there's still times, I mean, like 2 weeks ago, I had a request to do an analysis, and LMF was not involved, for instance. There's, we're getting better. We're getting the word out. Multiple uses for this AIM and LMF data. We have science uses. I'm playing around doing some cribbing for some continuous mapping to see if that can help expand our point-based estimates or design-based estimates to something that as useful but different use for management. There's it's called the Rangeland Analysis Platform. It's a recent remote sensing package, and AIM data is actually LMF, and I think NRI data are used to parameterize the remote sensing classification algorithms. Just 2 examples. There's plenty more. This is an example of an LMF-based report looking at the biotic integrity, deviation in biotic integrity from moderate departure. And this is by ecoregion. And this is just to give an illustration of how the LMF data, the impetus for LMF program. And this is the kind of stuff that comes out of the LMF program. A typical, there's no such thing, as I've come to realize. But lack of better wording, a typical terrestrial analysis using AIM data. So what happens is someone from resource management planning, horse and barrel program, sage-grouse program, says we need to know something about area A. And let's call area A an analysis area, or AOI. In this particular example, this is Malheur Field Office. This is the Vale District, that's where Malheur resides. This is a primary habitat management area, sage-grouse habitat. This is primary habitat management area clip, suggests sage-grouse supporting BPS. So it's not even the entire PHMA area. We have benchmarks, like what do we want conditionalized this place to be? Well, this is a very simple example. This is this one benchmark, and that's greater than 15% coverage. So the field defines basically the AOI. They hop into LMF and AIM database, and they pull out the points. They go, okay, 2015, 16, 17. Let's use all 3 years. So what points were monitored 15, 16, 17? They pull those out. They score each of those plots to meeting or not meeting based on, of course, the monitored indicators in this benchmark. And then we perform design-based proportional estimates. Using that information, we have a couple R scripts we have produced to try to sort of standardize that at the National Operations Center. And then voila, you come up with your answer. Proportionally, well, the state percentage. So 60% of this AOI is not meeting, 39% is. So this is where statistics stop. And the info goes back to the manager. Right? Unfortunately, and don't repeat this, but unfortunately, the field office wanted 70%. So like I said, this is where we produce our pretty little bar charts. And it is a little more than this, but we produce this information to them. So it sounds pretty simple, right? Yeah. Let's look under the hood. First off, PHMA. There is no such thing as a PHMA survey design. There is no effort to monitor PHMAs. However, we do have 4 other efforts that happen to overlap. Sage-grouse focal area. We have a 2016 Vail District frame, not to be confused with the 2017 frame, which is different. Not to be confused with the priority areas for conservation. These frames actually, as the thing goes out here, ACT goes up here, 17 goes out here and here. It's all clipped to the area of interest, and then we start to figure out the overlaps. 16, 17 SFA only. 16 and 17, 17 in PAC, 17 only. So this is the kind of slicing and dicing that we are faced with. When we follow the AIM schedule, measure once, use it multiple times. Yeah. Oh wait, there's more. We also have LMF plots. And we have LMF type 2 zone up here on the top, and type 1 here down on the bottom. And actually a little type 2 down here, and just for simplicity and infinite all. So here we have, PAC 2017, LMF1, the same thing, but LMF2. So again, the more you slice and dice, it becomes, I got a web's doing that, I guess. The more you slice and dice, the more, I guess in the literature they refer to as new frames. In my world, I refer to them as reporting units. So it's like everything overlaps. So here's basic inference area, it's called a reporting unit. And then anything and everything that falls within that point-wise is then analyzed at that reporting unit. If you have stratification, which nowadays we tend to, then it's by reporting unit by strata. So this is just a quick overview. If we're only dealing with AIM only points, basically create the frame and just recalculate the point weights by strata. Score each response point to condition costs, and then you just roll them up from strata reporting unit up to the area of interest. And typically we're reporting out at the AOI, not at the by strata, not by area. I mean, you can, but typically you don't. And so, just effectively roll that up using CAD analysis. Some of our field office folks want to see binomial or multinomial simultaneous confidence intervals, so we have various options to run for them. Now, this is AML. What about LMF? Integrating LMF has been an interesting experience for me. To date, version 2, I came up with a mechanism to facilitate computational efficiency. And I essentially overlay the aim points onto that segment, quarter section, modify to approximate 160 acres. And combine that directly. I call this integrating the points. The reasons you'll see in the next slide. Integrating them facilitates using, this is like the LMF standard formulation. Doing it this way, I can crank through it. It's logical. Analytically, I can show that it's logical and gives the expected results. However, as someone once said, yes, there are certain assumptions that go in here, equal size. What happens if a couple aim points fall within the same segment, which they haven't yet, believe it or not. Sort of like living in borrowed time. I showed this to a full professor of statistics, and the comment was, "Wow, that's novel, but messy." The bottom line is we're still working on that. I have tried integrating with the on the basis of inclusion probabilities weights. I don't know. I think so. I'm doing something wrong because I'm not coming up with something that makes any sense. So this is like, you know, if you have some inputs on this, that's fine. That's great. This is something we're definitely working on. Iowa State, our partners who come up with using generalized least square method. But here the intent is to aggregate, combine the estimates. And so it's basically variance weighted estimates of the two separate designs. So they're treating the designs as independent designs. That's good for some questions when you want to increase sample size of relevant subpopulations, improve coverage given individual surveys, and facilitate time assessments of time trends in a population. I heard that someplace. So for that, it's sort of, you know, the point integration is probably the best way to go. Did I miss? So just, yeah, okay. Just as a summary here. So our approach is to first, of course, generate the new frame, reporting you, whatever you want to call it. I do all the scoring and benchmarks, but you basically recalculate the weights after you have sliced and diced everything down to the reporting unit and strata. If this is an aim only, you only have aim data that is. LMF designs are used, and the point integration. We're working on a better way to do that. And an alternative, or for different types of questions, we're back to the GLS integration where we're integrating the design estimates. I think there's definitely a time and place we want to work through this to get it down. There are some issues. What if certain stratum are not sampled with the aim points? LMM by default actually does make inputs to those strata. So devil's in the detail, and that's what we're working on. Now, I think I will stop after this for some questions. I mean, to have discussion. So some technical issues still to be dealt with. Sure. But now, if you take a look at this, we're back to the AOI, and you can see the points right there. You think this is spatially balanced? Or would you want to, you know, run your randomization routine through this 5,000 reps, comparing SRS nearest neighbors to the nearest neighbors? Only to find, of course, that more than 50% of the time, An SRS sample was less clustered than what we see here, in particular within that little old one. So basically, I've done these tests for other examples, situations, and in short, randomization tests show that overlapping aim and an element designs tend not to be spatially balanced. And so we're back to, as your designs are not simple, and we had this symptom. And over here's another symptom. And it's like, oh my God, we got all this data. We spend $11 to $12 million a year collecting data. We're paying people to collect data. And so when folks in the field are like, hey, I got to do this analysis, hey, they're going to go like, hey, look at all this data. I don't leave any behind just because it's going to affect the spatial balance of the final samples. I want that data. I need to use that data. So some really topical questions here. Right now, we're not doing anything to handle that. Well, we are. We're putting on blinders and going, God, I hope I don't have to tell people, talk about this in front of real statisticians. Whoops, that day's up. Today's tomorrow, or tomorrow's day, or whatever. No, but seriously, I mean, this is a really, I think, given the kind of the situations that we have in terms of data, the frames, different frames, even with or without OLED, doesn't matter. It's like we're, at the end of the day, we're faced with this stuff. And the question is, do we want to do it the best we can? Do we want to do it right? You know, we're also in a position where eventually this stuff ends up in court. And and that, you know, I'm running out of agencies to switch jobs. I went to Park Service, USPS. Hey, you guys heard? Okay. So no, this is a very real question and issue here, a technical issue worth delving into. The other thing, and I'll just hit this real quick. You folks have access to the slides after the show here? Okay. Tony approached this subject just a little bit, and that's using integrating targeted and probability data, samples. And we have situations where we have, here's a case, here's an aquatic site, example. Scott's on the talk, I had to put in an aquatic sample, discussion point. So here we have 15 targeted sites and 54 aim sites. And the question is, you know, can we combine those 13? They would add to the sample size, add to the coverage. The terrestrial side, we have plots. PLM has been monitoring plots for 30 years, not using, you know, a method, but 30 years. And there's more than just a couple out there. And it's like a bit of a gold mine, potentially. So, like, how can we begin to use that information, either integrated directly or also, you know, multiple lines of evidence, which I really haven't thought about how to do. What we have come up with so far, and this is, you know, this is in the process of being evaluated. I've only run through this twice with real examples. And the Overton 93 paper that Tony mentioned, Paul and others, and sort of formalize some of the tests for evaluating representativeness of targeted sites, and and provide criteria for including them, not including them, with probability samples at the end of the day. So I just sort of put that into a functioning decision tree, where the first point is looking for representativeness of the environmental domains using coordination methods, doing multi-response permutation procedure evaluations of overlapping columns. You make the decision in this particular case, you would say, well, maybe except for that one point, but everything seems to be about the same. Similar similarity in the distribution between indicator values. KS test is like the second set of criteria. If that passes, you look at similarity in the correlation structure. Again, this is with some of the slight modifications, pretty much what Paul and others have promoted. And if it goes through, then you're down here and you're back to the assumption that Tony had pointed out. It's like, well, looks good, but you're going to have to go with it. And if we're biasing something, you just got to live with it. Alternative is completely kicked out. It's like, well, okay, we should integrate this way. But how about multiple lines of evidence? Question mark is, I don't know. Sounds cool. I don't know what that means or how to do it. I haven't thought that hard to think through it. So here are the test questions. Now I have a bunch because I was on a roll.
You guys have 2 slides questions. I'm not sure how you can throw those up there.
Okay.
Questions of you, we can tackle some of these.
Well, how about, maybe it would be, maybe you'd be a little more productive and in the spirit of community of practice, sort of morph these questions into how do we deal with spatial balance of overlapping? Do we have to? Is it really causing any problems? How can we look to see if it's causing problems? Perhaps that's maybe a nice overarching question to initiate discussion. And the other questions I have actually, what do you think of the decision tree and blah, blah, blah. I mean, I was really hurting that towards the end. So anyway, spatial balance, Tony.
Yeah.